Okay. Awesome. All right, so we got through those last two sections a little quicker than I would have liked, so we're going to have plenty of time here for this next section and anything else that you guys want to go through. So let's go ahead and get started. So the next thing we're going to do, now that we have a base for our application, as we saw in the last section, last part, now we can start bringing in cool things to build a really nice application. We've already got offline capability. We've got a native look and feel. Now we can start using HTML5 and W3C APIs. And that was, as I said in the very beginning of this talk, that whole HTML5E thing that I talk about in my book is based on these 5 specifications and the 5 browsers that they're most widely supported on. So it's really easy for developers to understand. Of course, you can use any other API. You can bring in WebRTC. You can get access to the camera in Android. You can bring in the video tag. All I wanted to focus on was enterprise data needs and what it takes to build a really solid application. And also some fun stuff, too. So let's do the funnest thing first, WebSockets. So every HTTP request sent from the server or the browser includes headers, whether you like it or not. And those headers come at a cost. So, sorry. So we've got uncompressed request and response headers can vary in size from 200 bytes to 2 kilobytes to over 2 kilobytes. And that's kind of what WebSockets and Speedy and all these new kind of protocols try to address, is making things faster and giving us full duplex communication. So WebSockets gives you that minimal overhead, full duplex through a single socket. And we're allowed to deliver things seamlessly to the client, and the client can also send stuff to the server very easily with a little overhead. This is what's required to detect WebSockets in a browser. There's frameworks like Modernizer, and any framework you bring in will offer some kind of detection. This basically just checks the window object and returns true or false. And it's as simple as you can get to detect the WebSocket object. So let's do a demo. All right. So if you have your mobile device or a laptop, will be fine as well. Go ahead and pull that out, and I'm going to get you guys to go to an address. Oops, that's what your remote will look like. So go to onslide.com, ONSLYDE. And you're going to go to this address, onslide.com/devox12, ONSLYDE/devox12. If you have a device or browser open, go there, and I'm going to show you this WebSocket demo. You'll be able to participate. All right, so if you pull up a phone, which I'll do here, actually, let's do this. Let me stop mirroring for a second. You can see all the votes coming in. And these are all the people that just decided to pull out their phone or go to a web browser. And this is what the remote looks like. So let me drag this away for those not wanting to participate. now. Give me the arrows. It's not going to. Yeah, it's beginning me. Okay. There we go. All right, so at this point we have 20, looks like about 30 people have participated. And as you see here, when I hit the no button, it's going to shoot over one more, or it should if I'm connected. Let me see. I may have to refresh. No. It's completely broken. This is a prototype. Actually, in my talk on Thursday, I'll be giving a conference talk, and I'm going to use this throughout the entire talk, so hopefully it won't break then. But as you can see, we've got, roughly 30 people have voted. And basically what this did, it established a WebSocket connection with your mobile phone and with my server on EC2. It's a very small EC2 micro instance with limited functionality. And it basically allows you to vote through the remote control. So this has changed the way that I give my talks, all because of the real-timeness of WebSockets. I use this tool in most of the talks I give, and it allows the audience to participate with me as I'm talking, and they can choose the direction that I go. They can, the WTF button, which stands for why the face, by the way, it allows them to silently raise their hand and tell me, what are you talking about, Wesley? We don't even, you need to move on or whatever. So it's a way to get props as well. And so that's basically what it does. And so the cool part about this is when I move to the next slide, it takes the tally of the majority votes here, and it goes to whoever voted the most. So at this point, I'm going where the audience guides me. I'm kind of like a puppet on a string, and you can tell me which way you want me to go. And for the ones that voted against the way I actually went, so let's say you voted no and I went to the yes part, I could send you data through WebSockets with links to find out more about the content I didn't talk about. So you could just keep going and going with this concept, but it's all to demo WebSockets, and that's, like I said, I use it in every talk. And then you can go to the next one, and then you can have more options to vote. Let's see if it lets me vote this time. No, let me refresh here. Yeah, I'll definitely have to get this fixed before Thursday. Nope, still not working. All right, but anyway, it kind of worked there for a minute. So you see how this opens up new doors, and it really showcases a use case for the mobile web. I mean, you can talk about native all day long, but native versus mobile, whatever, but they all have their particular use case, and this is one for the mobile web. This is instant where you can ask the audience, say, hey, pull out your phone, go to this simple address and vote, and it allows them to do that without having to install a native application. Why would you want to install a native application for this purpose? So this shows you where kind of the mobile web is capable of really kicking in, and that's in the real-time kind of spectrum of applications. All right, so let me mirror this again. So to create this really wasn't that hard. So we have So when we call a WebSocket event, basically, you know, it's all standard API stuff. You have WebSocket open, on message, on close, and all these things are standard JavaScript API calls. And so what we're doing is we're allowing the remote controls to send us a yes or a no, whatever the vote is, and that in turn comes into our server, and you just parse the string, and then you spit back out to the slide deck, you know, what that vote was. And that is, like I said, very, very simple. One thing that I did with this particular WebSocket server, I had a gentleman asking me about Node.js and, you know, Socket.io and all these things. And like I said, this is raw WebSocket API. There's no wrapper frameworks around this. And it's got a simple fallback for polling. So if you're using an Android device which doesn't support WebSockets, it'll sit there and poll every few seconds. And that is a really inefficient way to do it. I mean, you should probably use long polling or a Socket.io framework or Vertex, which will be talked about this week as well, which I recommend if you're interested in WebSockets. So we have all these events on close, on error, and then the send, which actually sends our message. And that's pretty much it for WebSockets. I mean, you establish a WebSocket connection through a URL, and here I'm calling it ws this.ip, which gives me the IP of the server, and then the port. And then you say new WebSocket and the URL, and that establishes it. And from there on open, you tell it what to do on close and on message and all those good things. Let's see what else. So yeah, the graceful WebSocket object. So let's look at the remote. So the remote you use actually creates this thing called a graceful WebSocket. It's a jQuery plugin, and it goes out and it tries to instantiate it. And if WebSockets is available, it'll return me back a WebSocket object. If it's not, it'll start polling with jQuery. And this is kind of where this happens, is right here. So you have a function that says poll, and it goes out and hits the server. And that's how the remote controls and the audience know to update, which aren't using WebSockets. So pretty simple, but it's all kind of handwritten just to get a basic understanding of the APIs. So yeah, that's pretty much it. I hate it crashed, but you know, that's part of having a demo. So next we'll talk about web storage. So today you have two well-supported ways of storing data, cookies and web storage. And so we're going to focus on web storage. But cookies are, you know, much different than web storage because they implicitly send data back to the server upon each request through HTTP headers. So they kind of complement cookies, but they're really not a replacement for them. And again, cookies only give you about 4 kilobytes of max storage per cookie. So obviously that's not going to suit your heavy storage needs. So web storage can be accessed in 3 ways. You can call local storage dot whatever the accessor is, or through brackets and single quotes, or through the set item method. And that will set the data the same way, all 3 ways. So you have 3 ways of doing this, right? So they should all work equally and they should all be the same speed. Well, no, that's not the case. So this is how you detect local storage. Just like WebSockets, you have you call the window object to check to see if it's there. And this is web storage performance in Chrome on Mac OS, Chrome 20 on Mac OS. And as you can see here, you have set item and the 3 ways I just showed you to set a data point on this object. So small, here we're setting small set item small x. It's a very simple 1 character. We're setting the variable small to x. And then here we're doing the same thing, small equals x. And then here we're doing it with the brackets and the single quote small equals x. So 1, 2, 3, they're all the same thing, but they all perform differently, with local storage, small in the brackets, being the fastest way to store data on local storage. And that's in Chrome. Let's see, no, I didn't put the Firefox one in here, but let me pull that one up here. But in Firefox, it's actually different. And let me see if I can find it. Yeah, so this is Firefox 11 on Mac, and calling .setItem small x is faster in Firefox. It's actually a lot faster. So across the different browsers, Chrome using brackets, Firefox using setItem, they all have, and this is, this is something you want to look at after all your JavaScript's been concatenated, minified, all your CSS images are base 64. And you're sending one huge payload down to the client, you've done all the optimization you can do, you can start looking at stuff like this. But it's still important to know how these APIs act across different browsers. And so you have performance issues on different browsers depending on the way you store your data. So it's good to know. So another interesting fact about web storage is that it uses UTF-16 encoding, so it's not UTF-8. Every byte that you store in local storage counts for 2. So on the iPhone, mobile Safari, they tell you you get 5 megabytes of local storage. Well, in reality, you only get 2.6 megabytes of local storage because it is UTF-16 encoded. So something to, again, be aware of. You don't have a full 5 megabytes there if you're going to store like HTML data into local storage or JSON data. Okay, so let's look at orientation. So we've covered, at this point, we've covered WebSockets, web storage. Now we're going to look at orientation. So accelerometers, gyroscopes, compasses are now commonplace in mobile devices and laptops. So my MacBook has an accelerometer on it, which you'll see in just a second. This is cool, right? Because now we can write map apps all day long, and it'll tell us which way we're facing. That's the only use that we've seen for the accelerometer to know what our heading is or to know which way we're facing. But I want to challenge that API to do more and to do better, because it's so well supported across all these different devices. So again, boilerplate stuff, just how to detect device orientation event. I wanted to see how we could, change, how we could use the orientation API to create something cool. This may be cool, it may not be. So we have this demo. And right now you can see those numbers scrolling by. And I was actually going to use it here, but I don't think the lighting is going to let me. Let's see. Yeah, so you can't really make that. Well, you can a little bit. So let me see if I can do this. Where's my autofocus? It's not going to give me autofocus, is it? So as I tilt my phone, watch the page. The same app we just built in the last session. Let's see if it'll go. All of my pages are now navigating based on the way that I tilt my phone. It may be easier to see this on the laptop. So I'll pick my laptop up here and I'll kind of tilt it. Whoa. Well, sparks are going to start. So there you go. So you see the pages kind of navigating back and forth. There you go. So this is the same app that I demoed to you earlier but now we're just taking those divs, and with the accelerometer, we're shifting them. So this would be ideal for a slideshow with images, or it could be a new way. I mean, sometimes your thumb gets in the way, right? So you just kind of flip the phone back and forth, and you can navigate. Again, just trying to find different ways to challenge the APIs, to use them better. And another good use would be for reading. Like if you, the Obama website that I showed you earlier, which is like miles long, if you just kind of slowly tilt your phone down or up, it could scroll for you. The same concept. So there's ways to use the accelerometer, and this is one of them. So let's take a look at how we did this. So handle orientation event right here. Forget, how do you zoom in? There we go. So handle orientation event. We're using the WebKit CSS matrix that I showed you earlier to do the touch, and basically taking that same code and figuring out, you know, where we're at on the page with this window.getComputedStyle in the current page we're looking at. And then we call this detect tilt function down here at the bottom. And this basically says, you know, left to right within 30 of that CSS matrix value, and we're going to do nav either this way or that way. And we're going to flip through all the pages. So it actually has to go through, index all the pages, and tell you which way it's going, and all that cool stuff. So yeah, it's just a lot of code here to do the functionality I just showed you, and then we have a little queue system for the slides to go through, and that's pretty much it. I mean, you're looking at maybe 50 to 75 lines of code here to do that. So that is the orientation API. You can use it to get a heading. You can use it to find what floor you're on in a building, or you can use it to scroll through pages. So that's pretty much it. Next, we have geolocation. And I've got, after this is some really cool stuff too, so you guys do not fall asleep on me. So geolocation is not part of the HTML5 spec, but I included it in the book because it came up, or it got a lot of attention around the same time HTML5 did, and the mobile device revolution happened at the same time. So it would be wrong for me not to talk about it because it's huge for business and for app purposes. It provides a scripted access to geographical location information associated with the hosting device. So this gives us the capability to do geocoding, so get the latitude, longitude, use Google Maps service, and see where you're at. You can do geofencing, which is more used on native apps right now. There's more that the native apps can do with geofencing, but you can easily apply it to your own mobile web app, and that is where you draw a radius around wherever the user is, and you say, hey, we want to show him these ads based on his geofence. You put up a geofence around him in a certain state or country and show them certain types of content. And just general tracking, wanting to know where your users are, where they're going. And the API itself is device agnostic. It doesn't care how the browser determines the location. So that means that some devices may implement it differently. They may say that the user has to enter their zip code first before we can pull their geolocation data. And it may be controlled by the Wi-Fi. It may be controlled by GPS. You don't really know. All you have access to is the HTML5 API. This is one, you know, every API that I've showed you so far is basic window, checking the window object to see if it exists. But in this particular API, WebKit has a bug to where if you call navigator.geolocation, instead of this is the right way to check for it here. But if you, a lot of people just call, instead of doing the brackets, single quotes, to check that member of that object, you're going to use navigator.geolocation. That will activate, or it'll cause a caching bug to where that page will not be cached. So it's important to know these little nuances, and that's just part of the stuff that I wrote about in research. But you must be aware of these things, and you will become aware of them as you become mobile developers, mobile web developers. So there are many bugs to watch out for. So that's pretty much it. Geolocation. There's a demo. It's not too advanced. And everything that I'm showing you here today is html5e.org, and it has all the demos down here. So web storage, or no, web geolocation. And this just tells me where I'm at, and it'll rotate through. There's another bug in iOS that causes, so here we have geolocation, we check it, and show you this other bug. Yeah, so in the API there's this watch position function that will allow you to track your user. So you can do a one-time call to get their location, or you can watch their position, and the device itself will take care of polling and handling and figuring out where that user is. Well, there's a bug in WebKit for iOS 5 that causes the browser to shut down completely after 4 minutes. So again, another bug to watch out for. And these obviously get resolved as the devices progress. So, but like I said, you're going to support the current version, maybe 1, maybe 2 back. So you have to be aware of these things. And this just calls a set interval, window.set interval, and we're just calling the get current position instead of the watch position. And we'll just set an interval on that and call it. It's the easiest approach. Okay? So that is geolocation. And as you can see here, it's updating my, if I were to move my laptop, which I'm not going to do again, you would see it update. All right. So web workers. The final of the 5. And then we'll get into the really, really fun stuff. All right, so web workers interface spawns real OS level threads. You can pass data back and forth between these threads. And the only thing about web workers is you can't access a lot of the unsafe DOM capabilities like the document. There's a whole list of things that you cannot access through web workers, and we're going to see those in the demo. So you have to pass specific data in and out of the thread through serialized objects. They cannot be any complex objects, and you have to, and that serialization is taken care of for you. All right, so let's look at the demo. Should still have my server up. Yep. So here is a picture, and as the web workers are working, it's processing this image data and taking it and just using an open source library to add these kind of pixel effects to it. It's pretty simple, but each one of these rows that are coming down are handled in a different thread. So this image is processed 8 times faster because I have a thread pool of 8 WebSocket connections. And I'm going to go through the code and show you that. Here it is in a much simpler form, processing. Because most of the demos that you see for web workers is processing prime numbers. So I got to show you a prime number example here. So this is processing prime numbers on different threads. And one thing I did is I used a thread pool another guy had created and wrote about on dzone, and brought that in and added some improvements to it. And so now you can actually see what thread I'm getting my prime number back on. So each one of these colors, like this color is thread number 5, this darker green is thread 7, so each color is a different thread. And as I refresh my browser, you'll see that there's no real control over how those prime numbers are processed in the browser. They're just spawning off threads and returning those numbers. So let's take a look at that and see how that works. All right, so here I created a very simple API. It's called workers, and you give it your worker script. So we have this file over here called worker1.js. I want to tell it how many threads I want to use. So if I set this to 2 threads, go back over here, hit refresh. It's only going to use, that one used 1 thread. That one used 1 thread. Well, maybe it'll only use 1 thread. I'm setting myself up for failure here. So y'all just bear with me. There we go. So when I set it to 3, it uses 2. Like I said, there's no guarantee on how many threads it's going to use because the browser controls how it wants to process this data. But WebKit actually gives you a separate thread to operate on. So that you can control the thread level, and you can control. So when 1 thread's done, it hands me back a prime digit that's been processed, and I insert it into the HTML using inner HTML, and that's pretty much how that's handled. So let's look at the code. Yeah, so you've got this thread pool, and you declare the size of it, and it's really kind of pointless for me to walk through the details of this code, but we're basically shifting numbers off the array and kind of managing that through this thing called a task queue. Let's see what else. So we run it. We've got a pool. It's all basic stuff. And here, these final calls is where I'm handing it. I'm saying here, start at 10, start at 20, start at 30. So it kind of processes the same number from those starting points. And that's where we get our prime numbers from. So yeah, that's the boring prime number example. But it's using a thread pool, which most of the time you don't see people using. So the whole point of this is that Web Workers is capable of much more. The browser as a platform is capable of much more, and the surface of that is just starting to be scratched. If we're writing small custom thread pools right now, I mean, imagine in a few years what's going to be taking place inside of the browser. So very powerful things happening in HTML5. Let's see what else. Yeah, so like I said, every demo I've showed you here today, and this is not a shameless plug, it's kind of a valuable resource. You can use responsive design there. Okay, the book's not there anymore. So you've got the slide, the touch, the orientation, web workers, web storage, and you can go back through and see exactly how I did these things. Okay, on to the fun stuff. So now we're going to look at performance. Performance in the browser. And this is, so hour 3, performance. Client versus server UI. So just to give you a little preface as to what this is about. So when I took a contract with CNN earlier this summer, I was put directly on CNN.com to improve the performance of this page. And it's amazing when you have a site that gets 60 million hits per day, and you get to look at that and really tweak it out and see how you can squeeze some performance out of it. And CNN's kind of the poster child for slow websites, so it was kind of fun for me to do. So let's talk about server-side generated markup, and then we'll get into that. So between 08 and 09, the HTML generation on the back end broke down, and we started seeing these things like progressive enhancement with AJAX and kind of decorating the page with asynchronous calls and delivering those to give the user a better experience, to deliver content faster. And so this forced us to create better APIs and more efficient ways of delivering JSON and XML down to the client. And this kind of led into the whole JavaScript MVC, MV framework era that we're in right now. But client-side generation pros, you know, you've got the server-side generation. We know it's not, we don't want to be tied to the server. We don't want to depend on the server to generate our markup. What does client-side generation do? What's so great about it? It reduces server load. You've got this one-time payload that you send down, and that's it. And then you kind of decorate the page and use JSON on the fly. Uses less bandwidth, and you can also use CDN Bandwidth. For those of you don't know, a content delivery network. So jQuery provides a CDN, and the beauty behind that is if you don't have to host jQuery on your own server, you can use their CDN, and chances are that 50% of your users will have that file already cached in their browser, so they don't have to download that 44 kilobyte file anymore. They'll have it cached, and that will be 44 kilobytes you don't have to worry about, and a latency issue you don't have to worry about. It'll already be cached. So it's going to speed your site up that much more to use a CDN. And that's in cases where you're not concerned about security, because there's always a possibility CDN server could get hacked, someone could inject malicious code into your website, so on and so forth. And client-side generation, offline capable. Oops. So what are some cons? It can reduce performance of the device and browser, as we just saw. Activating geolocation in the wrong way, or accessing objects in the wrong way may cause the device browser to crash, and you'll never even know about it. Parsing JSON uses more memory. Getting that XML or JSON down to the client can use more memory, and storing all that, managing it in local storage, bringing it back out. And then hardware access can be a battery drain. So as you saw earlier with CSS3, we can have battery issues, and we can drain the battery on that user's device. The most notable client-side con is security. Web storage is not secure. It's very widely supported. You can store a lot of stuff in there, but it is not secure. And you're not going to have security until we get IndexedDB, and it is widely supported across devices. But the whole point of this talk is to understand what APIs are available to you right now, what you can use. So you got to give up security in order to use web storage. Of course, you can encrypt your data across the wire, but once it gets to the client, it's free game. And you bring all these, as I was telling someone earlier, LinkedIn uses a Node.js server for some of their content, and they use another type of server for another. They're kind of stitching their content together from different servers, and you're managing these frameworks, these different servers. You don't want to end up with a huge mess, and that's separating your code bases, managing frameworks takes special care, and that's what the JavaScript MV frameworks are kind of for. So let's see what else. So let's talk a little bit about performance. So we know kind of what to be aware of on client-side heavy applications, but naturally developers care about performance. We all care about performance. The product sales and marketing folks do not care. They just want the product out. They don't care if you unit test it, just get it out. Some do, some don't, but a lot of times we have to push back. Performance impacts the bottom line of the business, and that's one thing I wanted CNN to understand is, the better the faster the site is, the faster it loads, the better SEO you're going to have, and the better lead conversion you're going to have. And the business drops off when your site's slow. It's a huge factor. So Steve Souders, a couple of years ago, started talking about this experiment that Google, Yahoo, and Bing did. and it's actually really cool. So Google introduced a 0.4 second delay into their searches, and all the searches dropped by 0.6%. So just by adding a 4 millisecond delay. Yahoo introduced a 4-second delay. Traffic dropped by a full 5 to 9%. So that's pretty massive. Just your traffic is dropping off in relation to your delay in your search. And then Bing introduced a full 2-second delay, and their revenue per user dropped 4%. So that, again, is huge. Just the fact that 2 seconds can cause your revenue to drop by 4%. So on a more positive note, Shopzilla reduced page load by 5 seconds, and the revenue increased by 12%. So hardware was reduced by 50%, and the unique users doubled. So that just goes to show, you know, your performance really does matter on the front end, in the browser. So again, did this experiment with CNN, and we basically removed jQuery, and they were using another library called PROTOACULOUS from CONCATENATION and added that to the CDN. So we removed those out of the weekly builds or bi-weekly builds, and it improved site performance by 17%, and we almost had 1 terabyte of bandwidth per day reduced out of the data center. So that, just by breaking out jQuery from a, you know, as I was saying earlier, you know, today we concatenate and merge our JavaScript into one big file, but because jQuery, every release, every week, that one big file was being revved up another version. So revving that up another version caused the user's cache to invalidate, and they had to re-download that file. So you have to be smart when you're doing these performance techniques, and really think about what's being used, what's being cached. Do these things need to be concatenated? Do we need one huge file? And sometimes you don't. So let's do our final exercise. And this we can kind of take our time on. Phantom.js and loadreport.js. So what we're going to do, we're going to generate a load report, a load test report, so you can measure your site performance per build. And that's what we did. I wrote a script, and it basically integrated into our Bamboo build system, or, you know, it could be in Hudson, it could be in whatever, that'll automatically run, generate this report for you. So let's go ahead and do that. So this is load report, and let's go ahead and run it real quick. This is just a simple server I set up that will run and give you a report. So we're going to let that run, and I'm going to pull up the actual project. All right, so what that did is, now at the bottom of the screen you can see this table. And what we did, we used Phantom.js, and let me go out to Phantom.js first so I can show you. And all this is a simple download. You install it, no dependencies, and it's a headless WebKit browser. And it allows you to run the browser without actually opening the browser. You know, if you've ever used Selenium, it has to go through Open Firefox and all that stuff. So this runs the browser in the background without actually having to be open. It allows a lot of testing frameworks to use it, but for this case, I wanted to use it for its load reporting capabilities. So with CNN.com, we see what our DOM ready state is on interactive, what our window on load time is, what our ready state complete is, the elapsed load time, number of resources, total resource time, our slowest and largest, total resource size, and all that stuff. It also reports JavaScript errors as well. So, I mean, you could have this thing running in the background all day long, giving you really nice reports. And so if we open up slowest resources, it'll show us that our slowest resource is coming from an ad server, obviously. And, you know, sometimes it's different. Every load is different, especially on a site like a news website where content is changing every load with ads, and that's what's going to happen here. So largest resource is going to be this JS file that's been concatenated. And same here, this hplib JS file. So, great. So what else you got? So we have charts as well. So everything you just saw is kind of broken down at a much finer grain level. And you can see what the blocking time is, what the latency is, what the download time is, the total duration that each one of these resources took. So here's a GIF image, the header GIF image in it. And so these, just like in WebKit or other browsers, you can see these things, but in a actual physical report. So you've got blocking, latency, download time, asset duration, asset time, and a lot of other heavy fine-grained reporting capabilities. So that is all done through a very simple JavaScript file called load report. And load report is, this is where it starts, and it basically just, and this is out on GitHub as well, so if you go, let's see, GitHub. And you can go down here to the notes, and it'll show you exactly how to use it and install it on your system. But like I said, it's just a JavaScript file, and you can basically go through the code, see how how you can come up with the interactive, the DOM ready states, the window on load, the JavaScript errors. Let's see what else. On resource received, on load finished. So they give you all these callbacks in Phantom.js, and you can utilize those to pull this kind of data. So another cool part about this is the film strip. So let's see here. So if we go to so as I run this command, you will see images start to pop up. So each one of these images has a timestamp on it telling you when the screenshot was taken. So at 663 milliseconds, we can see that nothing's there. At 1 second, there's nothing there. At 2.5 seconds, we have a page that has some content delivered, but no images yet. 2.8 seconds, we have our images. 3.5 seconds, we have some of our gutter material on the right-hand side. And then as you go along, the page slowly populates to 6.3 seconds. So visually, it's a great way to see how your site is being generated and how it loads in the browser, or at least a WebKit browser. Gives you an idea for performance. And that is basically it for load report. Also has, you can also run a speed report, which that will generate the graph that you just saw. So and it will also produce your data in a CSV or JSON file as well. So you can get pretty much anything you need from this report. And that is all I have, I believe. Yeah, so that's it. In a little shy of 3 hours. Not too bad. So Any questions? Yes.
The amount of bandwidth that was used at CNN went down. But did you also see an increase in traffic?
That did not hang around long enough to find out. I actually went to another position after that, so. But I'm sure they do relate. I just don't have the measurements. So, any other questions? All right. Oh. Not very long. Couple days. The load report tool is, like I said, it's out on GitHub. I forked it from another library called Confess.js and basically stripped what this guy had done and used it for my own needs. The beauty of open source. Yes? I'm sorry, what was that? Yeah. Like I said, we could bring in as many APIs as we want. I just focused on those 5 for enterprise, data needs and really creating an app that works across as many browsers as possible. So. Oh, yes.
You're obviously very enthusiastic about mobile applications, but are there still some circumstances where you would advise native iOS or Android applications?
Yeah, native definitely has its, use cases, and as I showed more mobile web use cases, but anywhere from games to heavy. I think you get like 40 or 50 megabytes of storage on a native application. So it really depends. Security is another thing. So it really depends on what you need out of that application.
Yeah, but also for a media application. So you said that CNN wanted to make a web client, but if you take an example, an application like Flipboard, for example, they really make a very nice native application.
Oh yeah. Yeah, it's a matter of managing the existing infrastructure from how their content is produced to figuring out, how much is it going to cost us to develop a native app for this. So it's really bringing in a lot of different variables to figure that out. So.
Yeah, but still a bit surprising because Flipboard is not creating their own content, so with content from others, they are able to.
Oh yeah, no, tell me about it. Yeah, we try to make a case. As a developer, you can only do so much, right? So, sure thing. All right, thank you. Oh, yes.
What's your view on PhoneGap?
View on PhoneGap? PhoneGap's great because it allows you to develop to the newer APIs much more than I covered today. You can, develop to APIs today, and then when they become available in the browser, you can move that application to the browser and not have the dependency on PhoneGap, which would probably never happen, but it's an option at least. They're very involved in the W3C and open standards. Wikipedia actually uses PhoneGap. I helped them with a problem they were having, and it was interesting to see the PhoneGap being used for such a large-scale application because Wikipedia is very popular. Yes?
How easy is it to make an application that presents itself well for a smartphone and a tablet and a laptop? Because you have quite a difference in the screen state.
Yeah, that's where I was talking about the responsive design and bringing all that content onto a mobile device, and really you really have to decide if you want 2 code bases to manage and then how you want to present that content to the user. You basically want your user experience to be the best as possible and not just pushing all that content onto a small screen, you know, carelessly.
Yeah, we have too much white space on the template.
Right, right. Yeah. All right. Yes.
Have you ever used direct web remoting?
I'm sorry, what was that?
Direct web remoting, DVR.
No, I have not. No. I've used a few different, like Adobe Shadow, which has been renamed now, and Winery, I think is how you say it. Yeah, but no. Yes.
Used it on iPad, but as you said, there was a problem with the inner HTML on the iOS 3 device.
Yes. Yeah, and so that was the workaround. Interesting. All right, well, thank you guys so much for being here. Appreciate it.